For generations, the image of the American fighter pilot was one of a high-flying cowboy, a king ruling from the cockpit of a powerful predatory and often dangerous machine. Think of the legendary F-14 Tomcat, a muscular icon immortalized by Hollywood, operating in a world soaked in jet fuel and testosterone. Life on the edge was the norm, and catastrophic accidents were a frequent cost of air superiority. Then, in the 1970s, a new aircraft arrived, and to some purists, it was almost a disappointment. It was the F-18 Hornet. It didn't have the same raw, untamed swagger of its predecessors. But its genius lay not in its danger, but in its profound intelligence and reliability. The Hornet ushered in a new era, one built on the philosophy that the most valuable asset in the sky wasn't the plane, but the pilot inside it. It was a fighter, an attacker, a survivor, a marvel of engineering designed to be fast, lethal, and versatile, all while bringing its pilot home safely. This is the story of the aircraft that traded movie star charisma for battlefield supremacy, becoming the true, indispensable backbone of modern naval aviation. In many ways, its tale dates back to the early 1950s. This occurred during the Cold War, which had been ongoing for several years. Another truth that the U.S. was coming to terms with was that Russia was no longer trailing America in aircraft design. In fact, they had made great advances in the post-war years, producing a series of bomber designs that surprised the NATO allies just as much as their MiG fighters had. This is the Russian Tu-16, which NATO calls the Badger, a rather advanced aircraft for its time, with only 2 engines. The engines were the largest and most powerful jets of their day. The Badger's full-swept wing-quick speed and large bomb load made it a formidable opponent. However, due to its limited range, it could only have been used in the event of a European battle. The Tu-95, often known as the Bear, was not subject to similar constraints. This design proved to be a successful investment for the Soviet military, which used it exclusively for nearly 30 years. Its jet-driven propeller provided fuel economy, increasing its ability to reach North America from Russian bases. But the M4 Bison discovered in the late 1950s posed a considerably greater strategic threat. The Bison has the speed of a pure jet and the range of a bear. While Western planners legitimately feared its capabilities, they didn't know that the M4 was not manufactured in significant numbers like its propeller-driven sibling. A quick, high-flying target like the Bison required a different type of weapon than what fighters had carried before air-to-air rockets. Non-guided rockets were installed on the fighters of the day, which were built for high speed and climb, with some also offering exceptionally extended range and all-weather capability. Thus, the early Super Sabres Delta Daggers and Voodoos, as well as Northrop's Scorpions, all relied on this raw firepower to respond to the perceived Soviet threat. If a confrontation had occurred, a significant number of jet fighters from the Air Defense Command would have unleashed thousands of missiles to form a wall of destruction in front of the new Russian designs. As technology advanced, rocketry evolved, and the multitude of crude, unguided weapons gave way to a small handful of much larger and more sophisticated designs. Missiles were now directed, and some even had nuclear warheads to be fired far ahead of the launching fighter, forming a nuclear barrier far worse than regular rockets. The aircraft that carried this technology had to be fast and high-flying. But its mission of intercepting bombers meant that it would not be light and maneuverable, and it would certainly not be a fighter in the traditional terms that would have been understood even a decade ago. This dedication to producing an interceptor rather than a dogfighter left the Air Force vulnerable when the conflict in Southeast Asia erupted. Delta daggers were excellent for guarding American airstrips and other installations from North Vietnamese bombers. But no such attacks occurred during the whole conflict, and the 102s served no other role. Vietnam was a different conflict, and the aircraft that the United States Air Force would face were more akin to the classic definition of a fighter, highly maneuverable, sufficiently swift, and cheap to produce. In some respects, they were deceptively rudimentary. Against Western technology, North Vietnamese MiGs performed admirably in a dogfight. The F-4 Phantom was the United States' most successful fighter during the conflict. It was very fast and incredibly powerful. Boasting multiple types of guided missiles and a second crew member, a radar intercept officer, or RIO, to help manage its complex systems, proving to be the best tool the United States could bring to bear against the agile MiGs. However, the F-4 was initially designed as a Navy interceptor with missiles used to counter hostile planes rather than being capable of engaging them as a genuine dogfighter. Even before the Southeast Asian War ended, the Navy was looking for a more adaptable interceptor due to the F-4's revealed shortcomings in fighter-to-fighter combat, which it discovered in the Grumman F-14 Tomcat. With the Tomcat, no expense was spared. Carrier space is limited. Thus, it was decided that it should be dedicated to the best money could buy, which was the Tomcat. It employed variable sweep wings to allow for varied combinations, and despite its size, it was quite nimble. Using the Phoenix missile, it attained a range that the Air Force had only imagined for many years. Due to its adaptable design, the Tomcat could carry the same ordnance as the Phantom employed in Vietnam, along with a notable addition of a cannon for close confrontations and dogfights. Whereas the Navy sought a multifunctional replacement for the F-4, the United States Air Force chose to create a new dedicated air superiority fighter. McDonnell Douglas designed the F-15 Eagle specifically for this function, with a more defined purpose. The Eagle did not require the Tomcat's second crew member or a variable sweep wing, but instead had to combine incredible speed and range with agility and powerful weapons. The F-15 Eagle is still widely regarded as the best single-fighter idea available. Fighter design is as much a philosophical challenge as it is a technological one, and Russian thinking had taken a completely different approach. Their defense relied on a large number of sophisticated, but perhaps basic planes, such as the MiG-21. This aircraft earned a lot of respect in Vietnam, and it continues to give good value as a fighter even now. Opposing this was a United States mentality of striving for the finest quality, but the sheer number of Russian fighters forced the United States to reconsider its designs. Another factor influencing United States thought in the early 1970s was that many of the supporting NATO air forces were flying the Lockheed 104 starfighter, which had proven to be quite effective, but was rapidly approaching retirement. The starfighter was never widely adopted by the United States Air Force, but as a lightweight, cost-effective idea similar to the Russian MiGs. The 104 was mass-produced abroad by many of the United States allies. This highlighted a vast market that all of the major Western manufacturers hoped to fill. The French, with their Mirage F1E, provided a smart, lightweight fighter that might have easily replaced the 104 as a cost-effective aircraft. Similarly, the Swedish Saab Draken was presented as a very effective high-tech solution to NATO's objectives. The Draken was a fantastic idea, but both European models would have to compete with United States producers. General Dynamics had been out of the fighter market for some time, and they were keen not just to secure overseas orders from NATO countries searching for a replacement for the starfighter, but also to meet what was quickly becoming clear as America's need for a more cost-effective fighter than the F-15. The new jet would have to be acquired in the quantities that the Soviets were known to deploy, and the combined markets justified the firm investing millions in its new design. General Dynamics entered the competition with the F-16 Fighting Falcon. Externally, the prototype F-16 differed little from the later models. Right from the start, the project moved beyond the cutting edge to technology that was still in the early stages of research, such as a complete commitment to fly-by-wire flight controls, which use electronic signals instead of traditional mechanical linkages to control the plane. Despite the dominance of huge United States jet fighters, there has always been a school of thought that advocates the benefits of lighter designs such as the F-104 starfighter. A later design, the Northrop T-38 Talon supersonic jet trainer, proved the principle of light versus might by combining two tiny jet engines in a highly efficient aircraft. The T-38 was a brilliant, economical, and simple design that Northrop provided to the Air Force as a tool for training fighter pilots before they flew solo. This remarkable spin testing of the prototype demonstrates the fundamental soundness of the basic idea. Given the availability of such a proven and successful airframe as the high-performance trainer, it is unsurprising that its producers were enticed to construct a specialized single-seat fighter variant, the F-5 Tiger. This aircraft's low cost and good performance resulted in several overseas sales. Yet, like the starfighter, it did not fare well in the United States inventory. Overall, Northrop benefited from the fighter markets in the United States and Europe. The company continued to modify the F-5 shape to give even greater maneuverability, extending the area where the forward segment of the wing meets the fuselage to form a forward strake. The forward strake concept, which was the result of advanced fuselage research, was adopted into Northrop's next design, the F-17 Cobra, in the early 1970s, along with several other T-38 legacies, like as the commitment to 2 light engines. The Cobra was larger than the F-5 and featured many other advances, such as the twin-fin concept. But the model's lineage remained distinct, and Northrop hoped that the design, combined with the company's proven experience with overseas clients and a wealth of knowledge gained in producing lightweight planes, would propel it to victory in the fighter competition. The business canvassed the NATO Air Forces extensively with the idea of purchasing this revolutionary aircraft. As you can see from this footage, the plane's interior combined pilot comfort and high technology, though it lagged behind the F-16 in some areas since its flight control was not fully committed to fly-by-wire at the time. If Northrop can secure a significant part of the new fighter's prospective export sales, its California facility will be able to retool following the conclusion of F-5 manufacturing. They hoped, like General Dynamics, that their jet would carry the order for the United States Air Force's crystallizing need. In April 1974, the journalists, dignitaries, and military personnel gathered together to view the YF-17. Much was at stake, but Northrop had excellent reason to believe on that sunny Californian day, when the jet was first revealed to the public, that their aircraft would sell well. The contracts were quickly becoming the largest peacetime Western fighter deal of all time, since NATO countries and the United States Air Force's estimations had been revised upwards. As is customary in United States military procurement, the two United States competitors would first participate in a fierce fly-off battle in which the planes would be pushed to their limits. When Northrop and General Dynamics set their engineering teams against one another at Edwards Air Force Base in California, the consequence was obvious: it would be close. Both aircraft performed admirably, but in the end, General Dynamics won the United States Air Force contract with their Combat Falcon. The F-16 single engine, while more expensive than the F-17s, had the advantage of commonality in that the same engine was already in use in the F-15. Therefore, service skills and spare parts were readily available. Long before the flight, General Dynamics had committed its corporation to production preparations, taking a huge risk that it would win the day. This became an important aspect in the decision, since it allowed them to promise delivery of their aircraft far earlier than their competitors. The Cobra had some flaws, including an air brake that was deemed to be less than totally functional, as well as questions about its range. The Northrop plane, which came from a long series of light fighters, was undeniably impressive. However, with the economies of scale that General Dynamics would gain from its Air Force procurement, the Combat Falcon swept the pool of local and export markets as well. The F-17 was left to the annals of history, another failed design. The final card General Dynamics used to secure European sales was to offer NATO countries a big share of the aircraft's manufacture for their local businesses in a convoluted offset contract. This meant that much of the technology created at General Dynamics' Fort Worth plant ended up being employed in Holland, Belgium, and other European countries to construct identical aircraft thousands of miles apart. General Dynamics expanded its sales outside of the NATO bloc to capitalize on its advantage. The Iranian emblem is placed on an F-16, but due to the country's turmoil, it will eventually be given to Israel. Fighting Falcons were also converted into highly successful ground assault aircraft and dedicated fighters. A pair of F-16s is depicted in service with the Egyptian Air Force. This Danish twin-seat version displays General Dynamics' high-tech approach to the lightweight fighter and attack requirement. Although the United States and NATO Air Forces had discovered a solution to their challenges, the United States Navy had to operate under different limits. The F-14 Tomcats had already been in service for some time, and they were performing admirably. However, the Navy was concerned about the exorbitant expense of their technology. Another issue the Navy had to deal with was that the A-7 Corsair II attack aircraft were nearing the end of their useful lives. This design was highly successful at the time. The A-7 Corsair II, developed from a dedicated fighter, saw extensive duty in Vietnam as a strike bomber, performing admirably and unopposed. However, as the 1980s arrived and their wings had seen many years of duty, a replacement was required. A third source of concern was that certain F-4 Phantoms, many of which were in service with the Marines, were still flying in duties that Tomcats would not be cost-effective to replace. Faced with these three factors, the Navy too required an economical solution. However, it could not consider the single-engine F-16 with its lightweight undercarriage as a viable solution. As the Phantoms and A-7s aged and the cost of large numbers of Tomcats grew too expensive, the United States Navy looked for another type of aircraft. McDonnell Douglas, which manufactured the F-4, was fully aware of the Navy's requirements and set out to find an economical multi-role solution to the issue. For nearly 40 years, the McDonnell name has served the Navy's demands. The company's Phantom I, the Navy's first jet fighter, flew for the first time during World War II. McDonnell's first production design, the Phantom I, was regarded as a significant achievement at the time. The Navy was impressed with the company's ability to work within the demanding specifications of carriers, which varied greatly from Air Force requirements. The Banshee was a significantly upgraded variant of the Phantom with the same form, but more powerful engines. This aircraft, seen flying in front of a Phantom I, was a complete success. The manufacturer's second production design was extremely successful and confirmed its reputation. Its debut was timely, since during the Korean War, it provided aircraft carrier commanders with a highly potent ground attack weapon. McDonnell produced over 900 Banshees in St. Louis, putting the company on track to become a world leader in naval fighter design. McDonnell's next offering was a single-engine aircraft with a swept wing. Initially underpowered, the design was successfully mass-produced as a fighter and reconnaissance aircraft. Its arrival marked the beginning of naval usage of guided missiles. The F-4 Phantom II was the St. Louis company's best achievement. Over 5,000 were constructed to meet naval and Air Force requirements. McDonnell's 25 years of dedication to the Navy's particular difficulties had paid off, and he was now wealthy enough to purchase the massive, long-established Douglas Company. In the late 1970s, McDonnell Douglas shifted its focus to meeting the Navy's most recent requirement. McCare had some design and financial participation in Northrop's F-17 project, and he believed the Cobra's potential was so tremendous that they set out to find and remove the few major faults in the package. It is available in two versions, fighter and attack, and may easily meet the Navy's requirements. The company took the F-17's basic layout and, using their extensive naval knowledge, redesigned it. To fit into a carrier's limited space, it was required to have folded wings. The new aircraft would have more range, more powerful engines, and a completely rebuilt cutting-edge cockpit housed in a completely remodeled front portion. There were thousands of adjustments. New forward portions and wings were to be built at McDonnell's St. Louis facility. But the majority of the fuselage and fin were to be manufactured at Northrop's Hawthorne factory, using jigs designed for use on the F-17 project if it went ahead. Thus, two large aviation corporations, both of which were relatively new, having not existed before World War II, joined forces to produce the aircraft. A pilot enters the Advanced Flight Simulator, which provides exact indicators of the aircraft's performance in a variety of scenarios before the design is fully produced. In just a few years, the displays introduced to the basic F-17 cockpit have improved significantly. The navalized F-17, renamed the F-18, and given the designation Hornet, made steady progress in development, and prototypes were put into production. The latest materials were chosen to give strength and lightweight, increasing the aircraft's overall performance. Naval aviation standards for planes that can fly from any aircraft carrier in the world are highly strict, and each component for the new type was thoroughly tested. Naval personnel working alongside McDonnell engineers examine a mock-up of the first F-18 Hornet. Made of wood rather than manufacturing materials, this model is a decent representation of what naval crews can expect from the actual thing. As a bonus for the program, the Mac Air had the YF-17 prototypes. These were flown regularly, allowing service and corporate pilots to get experience with flight characteristics similar to, if less advanced, than those of the new aircraft, which was still being assembled on the St. Louis production line. The Navy insisted on a much more robust undercarriage in the rebuilt Northrop design to withstand the destructive impact of putting tons of high-tech to a quick stop on a moving ship deck in a couple of feet. The completely reworked forward section and McDonnell's wings, both made in St. Louis, are brought together in preparation for mating with the fuselage manufactured in California and flown in on an Air Force freighter. Each section is fully integrated into a module or aircraft set. Although McDonnell modified the plane such that the Navy could use it, it was evident that Northrop played a significant part in its creation. The F-18's resemblance to the original Cobra design leaves little doubt about how thoroughly thought out the F-17 was. Pipes, cables, and couplings from California are flawlessly matched to their Missouri counterparts, resulting in a great fighter aircraft designed to meet at least two Navy requirements. The first of 20 pre-production F-18s leaves the McDonnell Douglas production facility. Service representatives and other dignitaries mingle as they examine the born-again fighter design, a true phoenix from the ashes, which is hoped to meet the Navy and Marine Corps' needs in both fighter and attack versions. The F-18 performed flawlessly on its first flight. The massively strengthened undergear, a far more substantial component than that required by its F-17 forebear, is lowered. Before any fighter can enter service, pre-production versions are tested to and beyond their limitations. Each of the 20 pre-production aircraft will be assigned a specialized duty to test the Hornet's capabilities. The maneuverability of some aircraft will be tested at high speeds. Others will be tasked with testing weapon carriage and release, while another will handle the arduous and demanding duty of spin testing. The Hornet had exceptional spin capabilities, and control was rapidly regained. In disorienting situations, the modern fighter pilot can rely on computer instructions displayed on a visual display. Another of the initial 20 ended up in the hands of the Air Force, where it was treated to harsh weather in an artificial setting while looking disheveled and sorry for itself. Intense cold and intense heat would be applied to the aircraft to test for even the smallest defect in the design. Back in naval hands, one of the test F-18s, all of which had blue or red markings on the wingtips and nose section, was subjected to carrier landing and takeoff operations at a land base. Landings identical to those required on a carrier are common. This test series demonstrates the most striking phenomena. Catapult takeoffs and high angle of descent landings tested the prototype F-18s. In strong crosswinds, computer-controlled surfaces struggled to keep tons of high-tech moving in a straight path. The first F-18 carrier landings occurred on October 30, 1979, with Lieutenant Commander Dick Richards at the controls. Prototype number 3 was to be subjected to continuous sea testing, including takeoffs and landings touch-and-goes. Finally, the ultimate challenge ship, landings at night. The prototype F-18s were put through their paces, providing insight into what the Navy could expect from its new economical high-performance fighter and, by extension, the planned new attack aircraft. The combination of McDonnell's thorough understanding of naval requirements and the original ingenuity underlying Northrop's ingenious evolution of sophisticated lightweight aircraft impressed the Navy as a viable solution to its challenge. Interestingly, the general design was so good that it was never required to create separate fighter and attack models. The plane had enough flexibility to perform both functions, eliminating the need to duplicate the aircraft in the all-too-limited space on board the aircraft carrier. By November 1980, the Navy was ready to accept delivery of the first FAA crew. The Hornet is put into service with the customary ceremonial that goes along with such significant occurrences. Captain Partington, commanding officer of the first squadron to receive the FAA team, will undoubtedly be filled with pride. This is one of the first two-seat versions constructed to familiarize crews with how to operate what was quickly becoming one of the most essential aircraft in Western defense. The Marine Corps' first jet was honored with comparable fanfare, as the Corps received the aircraft that would replace its aging F-4 Phantom fighters. Some of the squadrons that are currently using McDonnell's cutting-edge technology may trace their roots back to when McDonnell was merely an aircraft parts manufacturer. Flying Leathernecks were likely to achieve the same level of success with their aircraft as they had with McDonnell's famed Phantom II. The FAA team was about to go into full deployment with both services. Marine pilots fly alongside Navy pilots in identical aircraft, albeit their tasks might differ substantially depending on the mission objectives. However, the Hornet was not intended to be used just on carriers. Reversing the failure of its F-17 predecessor, it was able to secure numerous export orders. A nation that formerly had both Northrop and McDonnell aircraft ordered CF-18 Canadian Hornets. Canada had historically preferred 2 engines over 1 when flying in tough areas. A 2-seat CF-18 flies over Canadian airspace. If you look closely beneath the cockpit, you'll notice a clever Canadian innovation. The lower surface is painted with a dark form intended to deceive enemy pilots during a battle. At high speeds, an opponent may be unable to distinguish between the top and bottom of the Hornet. Air Commodore Rosa, the officer in charge of Australia's F-18 purchase pilots, a United States Navy Hornet. Australia ordered the F-18 to replace its old Mirage fighters, and much of the aircraft's components were to be constructed on the island continent, where it would also be assembled except for the prototypes. One of the early Australian planes is being put onto a C-5A transport in St. Louis. Consumed by the C-5A, it is taken across the Pacific to Australia, where it will serve as a pattern for 75 more aircraft. The high-tech fly-by-wire, the advantages of the twin-engine design, and the increased toughness put into an aircraft For the rigors of naval aviation, all combine in one superior model that will serve as the Royal Australian Air Force's front line of defense for many years to come. Another country to spend extensively on the F-18 after it defeated the F-16 in a closely contested competition was Spain, which had recently joined NATO. This must have been a source of great happiness for Northrop and McDonnell, as they were able to share the export sales that the F-17 had not received. Following a rough start in which it narrowly lost to the F-16, the Cobra, which evolved into the Hornet, arrived. Not only is it successful in its initial mission, but it also excels in the most difficult of all fighter roles, the Navy fighter. The F-18 is a clear winner across the entire fighter spectrum. The F-18 Hornet emerged from the F-17 Cobra, which lost the United States Air Force's lightweight fighter competition. The United States Navy and McDonnell Douglas saw potential in the F-17's twin-engine design and agility, adapting it for carrier operations. Combining Northrop's airframe with McDonnell Douglas's carrier expertise, the Hornet became a versatile multi-role aircraft capable of both fighting and attack missions. It replaced the A-7 Corsair II and F-4 Phantom II, streamlining the Navy's carrier air wing. Reliable and adaptable, the Hornet served as the backbone of naval aviation for decades, leading to the advanced Super Hornet. A wonderful plane.